The complex conjugate root theorem. Let f of x be a polynomial with real coefficients. And we've seen that type of thing with some quadratics in the last three examples. If a plus bi is a root of f of x, then its conjugate a minus bi is also a root of f of x. And remember, this is what happens when we have real coefficients. If we have real coefficients, then when we solve the polynomial equal to 0, we get any complex roots in conjugate pairs. Think carefully about that. For a polynomial with real coefficients, the complex roots appear as conjugate pairs. For example, a polynomial with real coefficients of degree 7 will have at least one root. Now there's a reason for that. If we're talking about degree 7, a bit like a cubic, it must either come in from the bottom of the graph and leave through the top, or go the other way around. Come in from the top and leave from the bottom, which means it's got to cross the x-axis at some point. So it must have at least one real root, so one root which is wholly real, and a maximum of 3 pairs of complex conjugate roots. Let's just think about that with degree 7. So what you could have is it just goes here, it wiggles about a bit and goes off the top, and that one there would have one real root, and it would have 3 pairs of complex conjugate roots. However, what you could have is a situation where it does something like that, maybe a little wiggle, and we can then see that we have 3 real roots, and that means we must have 4 complex roots, or 2 pairs.